you, Anna. Marta, Miralles from the Catalan Fire Service, who will talk about the definition of strategic management locations in Catalan massifs. I can remind you that, as I mentioned before, we have moved the slot for questions and answers at the end of the next session after the coffee break. So please keep your questions for then. Marta.
Jordi? Okay. In 2004, we introduced the concept of strategic management points, understood as a way of focusing the efforts of prevention on what the suppression needed. So not prevention done if measures were to help firefighters to stop fires, these measures should be where they were needed. That we called strategic management points, and now these strategic management points are introduced both in the forest policies and it's being introduced in the biodiversity policies. Because it's a planning tool. But what I want to talk you about is the way we have to evolve all these concepts because the way we fight fires has also been changing. We are no longer focusing our efforts on attacking the fire. We are focusing our efforts in containing the fire, and we are going towards fire management. And when I say containment, I mean we are not focusing efforts in all parts of the fires. If a fire is going to affect a higher value, and I'm not talking about surface, I'm talking about values. If a fire is going to affect a higher value, we are going to concentrate our efforts in parts of the fire and let that other parts of the fire arrive until containment axis. This is something that is being already done in most of the Iberian Peninsula during large wildfires. This means that the tools and the way of thinking have to evolve, because when taking these decisions, we are taking many decisions about the collapse of the firefighters. I think it was Sean that was saying we are not only a fire service focused on forest fires. We are attending car crashes, or we are attending industries, or we are attending, and we cannot collapse. We can no longer have no response. We cannot remain without response. Also because we face a lot of uncertainties when we are taking these decisions. There are a lot of models, there are a lot of simulators, but there is no good comprehension of forest fire behavior that can be automatized. Fire simulators give you a good idea of rate of spread, but it doesn't give you a good idea on how the fire moves. And so they are useful for a very concise part of the decision making. So to focus on this, we have then to see how do we prioritize opportunities to contain these large fires. And we have to take all these items into consideration. And also think that when managing fires, we are managing, actually, fire is one of the main managers of our landscapes. So we are making decisions involving the future of our landscapes and our societies. We have had many problems having automatized response, automatized decision-making on this. So many of the decision-making is done by expert knowledge. Because as I told you, simulators doesn't tell you what the fire is going to do. There's no tool that tell you what the fire is going to do. So I think one of the challenges we have is to have tools that help this decision-making. We don't need tools that make decisions for us. We need tools that help us understand better what is the relation between the orography and the wind. We need tools that help us to understand the roughness of the terrain. We need tools that help us in decision making, not tools that make decisions for us. So this is an example. This is Prades massif. Prades is like a big stone in the middle of a plain. So when the wind arrives there, it passes through the sides. Yes, both the north wind and the south wind do the same. We have a canyon in one part, so we have the flow of the wind is, Venturi. There's a Venturi effect, and it got stronger. So when we understand all this, and we understand many of these things, looking at historical fires, then we start making decisions. So I want to come directly here because this is tools that were invented during wildfires because they are useful for making decisions. This is, if you think about it, this is a risk map. This is a risk map that contains values in polygons and probabilities of the fire passing from one polygon to another. So this is a risk map with probabilities and values. Also, this is a tool that assumes that we have uncertainty of how the fire is going to behave. We have very concise places where we think we can have an opportunity. Those are the polygons, those are the axes of containment we may have, and there's a probability assigned to the fire moving through this landscape. Also, this is a tool that incorporates values. We can put values inside these polygons. So this is an example, and this can be also used for, of course, for prevention, and this is being used in Prades massif. So what this kind of thinking provides mainly is that it's not only where will I have an opportunity. This helps me decide what opportunities should I prioritize. Because when we have to decide what opportunities do we have to prioritize, one thing that we have to take into account is when the firefighters are going to make will need to be in a lot of in different opportunities. So these polygons are the more important polygons here are the polygons that expand the forest fires and that they have more possibilities of expanding the forest fires. If you think about it, this is a matrix of values and probabilities assigned to them. And this is a good way of measuring the probability of tactical response. So the challenges I wanted to put in the table is that we are making decisions in this under this uncertainty, that one of the main values that we want to protect is our own resilience as a fire service and not collapsing as a fire service, and that we need tools that help us make decisions, not tools that make decisions for us, understanding the limitations of the tools that are provided. And that's all for me. Thank you.